Okay, welcome to part three of the pollution lecture. This part deals with smog. And so, smog is just kind of a general term that means a mixture of air pollutants that come from combustion of fossil fuels and typically tend to be a problem in areas that have a lot of traffic. Um, First, we'll talk about industrial smog. And very simply put, if you are burning fossil fuels, one of the products of combustion is going to be sulfur dioxide. So you can see in this picture coming out of the smokestack there, where they're burning coal or oil, is sulfur dioxide. That sulfur dioxide gets into the atmosphere and it mixes with two things that are there normally, oxygen and water vapor, and it forms sulfuric acid. Sulfuric acid is a concern then as acid rain. And so here you do need to know the basic chemical formula. Just know that sulfur dioxide plus oxygen plus water is going to make sulfuric acid, and that it's a concern as acid precipitation. Um, your book talks about several smog events in the United States and I guess across the world. Um, London had an event in 1952 before there were a lot of regulations on pollutants, and they called it the killer smog, and it killed thousands of people. So it's an interesting little bit to read, although it's sad and kind of scary. But you need to go to your textbook and just read that little bit there about the killer smog. Photochemical smog is a more specific kind of smog that requires light. And that's where the photo part of photochemical smog comes from. Ozone is the biggest concern when we're talking photochemical smog because you need that sunlight in order to form ozone here in the layer of the atmosphere where we're breathing. So just know the basics of this diagram. When you have combustion, and they're showing here that the combustion's coming from a vehicle that's burning gasoline or diesel. Those two products contain hydrocarbons. You're going to give off your nitrogen oxides, basically your nitrous oxides and VOCs. Those are going to mix in the atmosphere with oxygen, and because solar radiation is there, solar radiation is kind of part of the equation, you're going to form ozone. Okay, so keep it really simple here in terms of understanding this. You don't need to know it as one big complex diagram. Maybe if you just remember that when you're combusting fossil fuels, um, your nitrous oxides are given off. They react, your nitrous oxides and VOCs are given off. They react in the atmosphere with oxygen and with sunlight. And the biggest concern here with photochemical smog is ozone. There are a handful of other things that are also created, but I want you to mainly remember that ozone is your product that you're concerned about here. Um, we've taken lots of steps to reduce smog, and specific states have taken problems with smog into their own hands. California is really a leader in making their own changes when there weren't federal changes that were being made. They put their own restrictions on power plant emissions. They have a vehicle inspection, like we talked about last week, where if you're going to be a driver and have a car on the road in California, your vehicle has to be inspected for emissions. And cars that are produced in the state of California must have very strict emission standards as well. And because of those standards that California themselves have put in as a state, they've put in place by themselves, they have seen a decrease in smog issues, but those levels, the ozone levels, are still in excess. Your book talks a lot about greenhouse gases and should they be regulated. And this is still a hot topic. In 2007, the Supreme Court ruled that the EPA could, under the Clean Air Act, regulate carbon dioxide and other greenhouse gas emissions. Basically, they could put limits on emissions for companies. And in 2011, they brought carbon emission standards in place for cars and for trucks. And then in 2015, the Clean Power Plan was launched. Now, the Clean Power Plan is up for repeal currently. There's a lot of changes being made to it right now. So you can read some current event stuff if you'd like to learn a little bit more about what's happening with the Clean Power Plan. But a big part of the Clean Power Plan is cap and trade. And you need to understand what cap and trade means. We talked about this a little bit first semester, but remember, in a cap and trade program, whether it's on emissions or maybe even if it's on fishing limits, the cap means that there's a cap or limit set for a particular emission. What you can do then is you can trade basically your polluting rights with other companies if you would like. And when I say trade, basically you could sell or buy polluting rights from other companies. So if you have decided that you're really going to clean up emissions in your company or in your factory, then and you have leftover polluting rights, then you can sell those and make money off of that. So cap and trade is used a lot in different environmental plans, and make sure you understand what that means.